Hi, welcome to the channel Coder's Arc, where we unravel the world of coding and architecture together. And today I'm going to talk about two very basic yet very powerful configurations from SQS, the visibility timeout and the delay queues. While they are very basic configurations, I have seen that most developers are either not familiar with these configurations or not leveraging the full potential of these configurations. So my goal from this video is that you understand these settings thoroughly and are able to apply them to your serverless solutions so you can see the full power of these settings. So let's dive right into it. Before we dive into the concepts of visibility timeout and delay queues, let's do a quick refresher on how SQS works. SQS implement the producer-consumer pattern, where a producer publishes a message at the end of the queue, and the consumers are constantly polling the queue and pick up messages at the front of the queue for further processing. If you want to see more details on how SQS is set up and how the dead letter queue configuration works, I've done a previous video and you can search through that video to understand more details. But for now, let's look at how visibility timeout works. What is SQS visibility timeout? The visibility timeout is a configurable setting for each message in an SQS queue. Whenever a consumer retrieves a message from the queue, the message becomes invisible to other consumers for the duration of the visibility timeout. During this time, the consumer processes the message and then deletes it from the queue once it has successfully processed. Now, if you take a closer look at this diagram, you can understand the concept of visibility timeout. This diagram clearly illustrates the concept of visibility timeout. The time is shown on the x-axis. Whenever the first receive message request comes for a particular message, the message is returned and the visibility timeout is started. Now, when there are further more requests for that particular message, the message is not returned because the message is invisible to other consumers that are polling the queue. Now, if the visibility timeout expires and the message is not able to get processed successfully, then the next receive message request that comes for that particular message, the message is returned to that consumer. But if the message is successfully processed within the visibility timeout, then the consumer picks the next message from the queue. There are two main benefits of using visibility timeouts. The first one is preventing duplicate processing. Imagine a scenario where there are two consumers that are polling the queue at the same time for the same message. If there was no visibility timeout, both consumers are going to pick up that same message and process that message twice. This could lead to some erroneous scenarios. For example, creating a duplicate entry in a database for the same record. The other purpose of visibility timeout is that it allows for individual setting for individual message processing. Imagine a scenario where one message takes a little bit longer to process than the second message. In that case, you can configure each message to have its own setting for visibility timeout, and this allows for a better control over the processing of messages. Now, in closing, I would like to emphasize on some important notes on visibility timeouts. You have to set a reasonable value, neither too high nor too low. If you set the value too low, it will not give the consumer application enough time to process that message. And if you set the value too high, and for some reason if the consumer code is not able to process that message and throws an exception, it means that the next consumer who would be willing to pick up this message cannot pick up this message until that high visibility timeout expires. The next important note is handle intended duplicate processing in consumer code. Now imagine a scenario where one consumer is processing the message and the visibility timeout expires, and now the second consumer starts processing the message again. Your code should be able to handle such scenarios and able to put guardrails around processing the duplicate message. We've already talked about configuring dead letter queues. You can reference my older video for that. And finally, you should have thorough exception handling. If there is an error that occurs during the processing, the code logic can retry or extend the visibility timeout, and I've provided a small code snippet here. If you want to pause the video here for a quick look, you can do that. Now let's talk about SQS delay queues. Delay queues is a concept and is useful in a scenario where you want to ensure that messages are not immediately available for processing but are instead held in the queue for a specific period before becoming visible to the consumers. The difference between SQS delay queues and visibility timeout is that for delay queues, a message is hidden when it is first added to the queue. Whereas for visibility timeouts, a message is hidden only after it is consumed from the queue. The range for SQS delay queues is 0 to 15 minutes. Now, if you take a closer look at this diagram, it can help you understand the SQS delay queues concept in more detail. This diagram clearly illustrates the concept of SQS delay queues. You can see that the time is plotted on the x-axis. Whenever the message gets put on the queue for the very first time, the delay queue timer starts. During this time, no consumer is able to pick up the message for processing. Whenever the timeout expires, at that time when the first polling interval hits, the first consumer picks up this message from the queue and begins processing it and kicks off the visibility timeout. After the visibility timeout expires, the next consumer can pick up the message for processing. Hopefully this clearly illustrates the concept of SQS delay queues. Now, one of my observations has been that most developers understand the concept of SQS delay queues, but they don't really understand in what scenarios is it needed. So here I've tried to illustrate that through a diagram. Imagine a scenario in which a producer is doing some processing on a record. As a part of that processing, it first publishes that record to the queue, and then it also does further more processing and pushes that message in the DynamoDB. Now imagine while the producer is still processing that record, the consumer picks up that message from the queue and begins processing it, and it may lead to some erroneous scenarios in the sequencing of the workflow. In such scenarios, it's best if the consumer can wait to pick up that message until the producer is done processing that record and pushing the message to the DynamoDB. Now, this diagram illustrates this concept, but there could be many other scenarios in which the SQS delay queues are needed, but hopefully this gives you an idea of why it is needed. So, I have covered the visibility timeout and SQS delay queues in detail in this video. If you have any more questions, feel free to ask me in the comment section. For now, please hit the subscribe and like button if you found the value in this content useful, and goodbye for now.